So now we can start building our investment model, and the purpose of this video is to show you the computation logic behind the profitability analysis, basically to compute cash flows and net present value. Now let's see what kind of investment case do we have. It's a new plant to produce a new kind of soft drinks for a big soft drink producing company. And now let's look through the information and put all the required data inputs into the model. So our first statement is that our expectations are that the project is no more risky than the existing business. What does it mean? It means that basically we can discount our new project at the same rate as we discount our present operations. If you are not from finance, please check out the discounting in Investopedia or Wikipedia, and that would be very useful for you. And the discount rate that we are using for the current operations is 10%, and that is nominal rate. So let's say discount rate 10%, and we want for now to leave a note that it is nominal rate. We will return to this issue in the next video. What else do we know? Our expert engineers have calculated the construction costs of the plant to be $10 million. And construction takes 2 years, and the cost is evenly divided into both years 0 and 1. So even before the construction cost, what we have is a timeline. So let's start with the timeline. Years. It starts from 0, and it's a common thing to start investment project timeline from 0, its basic year, and you'll see then why it makes sense when we'll get back to the discounting. And in order to make easily this timeline, we can just select 0 and 1 and then navigate on the right down corner and just drag. We don't know yet how many years we want, but I'll continue it later. So, and first investment costs. And now we are a bit out of the range, so just double click in here, or we can make it just wider. And it was $10 million evenly distributed in 2 years, so $5 million. Let's assume that we are working with $1,000, so we'll have 5,000 here and 5,000 here. And let's not forget that we are working with $1,000. The next statement is that when we finish with construction, we immediately start producing soft drinks. And our sales experts have estimated that the sales of the soft drink would be at first 1 million bottles per year. Sales, again 1,000 bottles, and 1 million bottles per year. And here, by the way, it would be totally legitimate question to ask why we start from the second year of our production. Why not right in here after the investment costs are incurred? It's not actually up to us to decide, but it's about the construction schedule of the project. If it really takes the whole year to construct the first phase and the whole second year to construct the second phase of the plant, and only after we finished and the year has ended, we can start operations and we can start selling the bottles, that then it would be the next year. If it appears that the construction can be finished, let's say in the middle of the year or at the beginning of the year, and operation can start immediately after that, then yeah, we might have some sales already in this year. But for now, let's assume that it takes 2 full years to build a plant of soft drinks, and we start producing drinks on the next consecutive year. So 1 million bottles per year for 3 years. So we have the same for 3 years, Ctrl+C, Ctrl+V to copy paste. But after that, when the soft drinks has become more popular, the sales will rise to 1.5 million bottles and will remain there. So we have 1.5, and we will remain there for a while. These calculations have been made with the best estimate price of one bottle at $2. So we can say here the price, dollar per bottle, and the price would be $2 per bottle. And we can calculate our revenue. It would be sales multiplied by the price. And price here we have just in one cell, so we lock it F4, so it doesn't slice with the copy in the formula to the right. And now let's check the units right here. We have 1,000 bottles, we have dollar per bottle price, and we want to have $1,000 in revenue. So it's okay, we don't need to multiply or divide by 1,000. So, and again, $1,000. And now we can just drag it to the right. Make sure that you have changed your revenues in accordance with the changed sales. The production costs of the soft drinks are $0.7 per bottle. Production cost. Again, dollar per bottle. And that was 0.7, right? And now we can say production cost now in $1,000. And that would be again our sale volume multiplied by the production cost, F4. Again, checking that the result changes with respect to the changed sales volume. Okay. The plant can produce soft drinks for 10 years. And after that, the machines can be sold at a scrap value. For 10 years, so we have already 7 years. We want 3 more for the production and 1 more where we will sell our machinery. We can just continue this. Will be, oh no, sorry, we need to grasp 2 of them, otherwise it changes. Let's check once again. We are producing for, count, 11 years. We delete this one. We are producing bottles for 10 years. And at the last year, we sell machinery at $92,000. $92,000. So it's scrap value. And again, it's in $1,000. Okay? The government has a corporate tax rate at 20%. Okay. Tax rate 20%. Oh, sorry. 20%. Depreciation of the initial investment will be done in a straight line in 10 years from the beginning of the operation of the plant. Depreciation. So, straight line depreciation in 10 years, meaning that each year the value of the investment will be diminished by the 1/10 of their investment costs. And that would be the case for all 10 years of operation. And here we again checking that the sum of the depreciation is exactly 10,000 or 10 million. That is our initial investment cost. And now we can calculate the tax rate. Here important thing to remember that investment costs or real flow of the money doesn't affect much the tax calculation or tax base actually, but what goes into tax base is our revenues, our production costs, and the depreciation. And let me for now mark them with yellow. So tax base would be our revenue minus production costs and minus depreciation. So instead of considering investment costs as minuses in here in the beginning, we are taking into account depreciation. That would be our tax base. And here, of course, I should not forget the plus scrap value at the end. It, of course, also tax deductible. And now the tax itself, and remember it's $1,000. It's our tax base. That is already in $1,000 because we calculated everything in $1,000, multiplied by the tax rate, and F4 to lock it. This is our tax. What else do we have is working capital investment. What is it? Well, assuming even in 10 years project is profitable and we are making money, it doesn't mean that, for example, first year of operation, we have enough money from the project to pay our bills for, let's say, production costs for maintaining the machinery. So what is working capital? It's additional investment at the beginning of the project to have enough cash to pay for their current bills. And that investment is estimated at $100,000 each year from the beginning of the operation of the plant until the fourth year of the operation. Let's put it into the model. Working capital. So first year of the operation, it's 1,000, and again, not to forget $1,000. So it's $100,000 till fourth year of operation. So 4 consecutive years until the fourth year, and after that $50,000 per year. After that it would be 50. Okay. The final 2 years of operation, the working capital investments are estimated to be minus something. What does it mean? It means that we actually paying back whatever we invested as working capital. So at the end, we'll end up with 0. 2 final years minus 225. 2 final years of the operation minus 225. Okay, and the last year when the plant is scrapped, the working capital investments are paid back. Sum of working capital across years is equal to 0. Now we have plus 150, so what we need is minus 150. Let's check again. Now sum is 0. Very good. And what else do we have is estimated inflation is 3%. Let's for now put the inflation in here, and for now forget about that. In the next video we are addressing that issue. Now what we can do, we can already make a line here and say that we are able to calculate the cash flows. And again, $1,000. And now it's pretty messy in here, and there are costs and revenues, both positive numbers. By the way, it's also depending on the modeling practices. You can do either all the costs negative and then revenues positive, and you just sum up everything in the cash flows, or you can leave all numbers positive, and in cash flows you already operate with plus and minus sign. I prefer to make everything positive because, for example, with the working capital it's both negative and positive, and you can really mess up there. Also, we have some numbers in here that, for example, sales or price that we are not going to use in our cash flows. So now I want to highlight for myself what goes into my cash flows calculation with plus and with minus. So investment costs, production costs, then tax, and working capital, since it's kind of investment, they are going with minus. So I want to immediately highlight them as red. And then revenues. And what else? Scrap value. Yeah, that's it. Those go with a plus into my cash flows. So we can start directly. Minus investment costs plus revenue minus production plus scrap value minus tax and minus working capital. That's it. And you see I'm highlighting everything in the first column already, so I can just drag everything to the right and I have at the end everything there, and I don't forget, for example, scrap value. Minus 5, minus 5, yeah, that's reasonable, checking that we are getting something that we want to. And yes, this is our values. And what we can do with cash flows, we can calculate cumulative cash flows, $1,000. So first year it's whatever we have, and second year is whatever we get that year plus whatever we had in the year before. And it's a good sign that approximately in year 7 we get paid back. But wait, those cash flows are not yet discounting. Usually accountants use these kind of cash flows, but we are investment analytics, so we are going further and we calculate discounted cash flows, or DCF, $1,000. So what is it? Well, we simply take cash flows at this period and we divide it by 1 plus our discount rate and locate, and in their power of the period. And now look at it, we are getting back to the issue with first year being 0. Now anything in the power of 0 is 1. So we get this cash flow divided by 1, so we get exactly the same amount, minus 5,000. But $5 million in the year ahead would be actually already less, substantially less, because of discounting, and 10% is pretty high discount. And now you see we are getting actually less and less money comparing to the undiscounted cash flows. For example, here we have the same values, but here this value being decreased. And to see it properly, let's also format it and make same amount of digits after the comma. Now again we are calculating cumulative discounted cash flows, and now I'm showing you another trick how to do it. So we can do just sum, and we are locking the beginning but not the end. And now when we drag it, each time we sum up everything that was before. So for calculating cumulative cash flows, both this way or this way are legitimate, and they provide the same results. And guys, I can say here that this one is our net present value. Now I want you to show several things. So it's last entry of the cumulative discounted cash flow, or it's sum of discounted cash flows, that is exactly the same, right? Or there is a function net present value, and we select rate for that, and then we select the cash flows. But here be careful, it starts discounting from the very first year. So what do? We select all the cash flows starting from the first year, and then we add cash flow of the basic year. Oops. And we have exactly the same number. So be careful when you are using built-in Excel net present value formula. it starts discounting at the very beginning. So what you need to do, you need to select cash flows from year 1 to the end, and then plus outside the formula some add cash flows from the basic year 0. Okay. What else we can do? We can calculate internal rate of return, and here the easy way to do is again using built-in formula however, and here we just take undiscounted values and it returns us 8%. What does it say us? Remember that if well, net present value is negative, meaning we are losing money, the project is not profitable. Internal rate of return less than discount rate, again we are losing money. And we can also calculate the payback period. The payback period is bigger than the project lifetime, but in case, for example, the discount rate is less than 10%, let's say 5, then we can see that the payback period is somewhere between years 9 and 10. And a fancy thing that we can do here is, by the way, conditional formatting. And let's do a new rule and format only cells that contain greater than 0, and we will do them say green. Okay, and okay, and add rule cells that contain less than 0, they would be red. Okay, so now you can clearly see the kind of timeline and the cumulative project discounted cash flows, and you can see that now the payback period is clearly between these 2 years of operations. But what is nice in conditional formatting, you haven't just colored it in fixed terms. If you change inputs, you get the conditional formatting changed in accordance with your rules, in accordance with your values. So now payback period is somewhere between 8 and 9, not 9 and 10. Okay. And notice, by the way, when I change the discount rate, my net present value changes, so now it's positive, but IRR, project internal rate of return, stays the same. We have exactly the same cash flows. I don't make any changes here. But now internal rate of return is higher than the discount rate, so project is profitable, net present value is higher than 0, and we can see payback period somewhere here. And what I'm not showing here, but what I want you to do in the task is to make the implement the computation of the payback period. So it would say, in 8 years exactly the project will pay off. Don't worry, you have a lot of guidance. Let's say Excel payback period, and you can find a lot of tutorials here, and there are a bit different methods, but you can use any of them. Just make sure that the logic is the same and you end up in between these years that is shown here. Okay, now that is it. That is the calculation logic. And I want to remind you first that here we have a mess of everything, inputs and calculations in here. Remember to do everything on the separate sheets. So you have clear input part and clear presentation part and separate calculation part where user are not supposed to do anything. But then also in the calculation, remember we have inflation. And remember, we don't have it in the calculation, and basically we even can check it. If we go to formulas and we say trace dependence, it will say us that it found no formulas that refer to the active cell. In contrast, if we put the selection into investment costs and trace dependence, we will see all the cells that refer to that cell. So we referred in depreciation and in cash flows. So this way you can check the logic of your calculation, and you can trace some errors if there are any. These errors are a headache because you usually forget how to remove that. Don't worry, there is a special button, remove all errors. So we'll talk about the inflation and the nominal and real rates and cash flows in the next video.